This is the first mini lecture for section 13.1 of the textbook. In this section we're going to begin talking about statistics. So it's a very different pursuit than we've had for the last several months or however long you've been in this course. So we're going to begin by just talking about data and how to represent data. A collection of data points is called a data set. Basically, just think of a bunch of numbers. You have this big jumble of numbers, and you can look at something like this, which is maybe a set of test scores from a class, and you want to figure out what are the overall trends. What's where did most people score? Did most people score high or low? What's the highest score? What's the lowest score? Is there some range that's more common? And you can't read any of that off of that. Okay, this is very opaque. So we'd like to come up with different ways of representing that data. And the first one we're going to talk about is called a dot plot. So I'm going to draw the dot plot here for this data set. And as I look at the data, let me go back to this. Let's see. The high score, say I see a 95. That looks like the high score. The low score, here's a 66. Yeah, that looks like the lowest score. So, we're talking about the 60s through the 90s. 60s, 70s, 80s, 90s. So in my dot plot, I'm going to draw a number line. I'm going to mark out from 60 to 100. '60, 70, 80, oops, sorry, 90, 100. And I want to mark all of the numbers in between here. So let me make the 5s kind of big also. And then we'll put 4 little tick marks between each of the 5s. So I want a tick mark for each point, not just the numbers that happen to be in the data set. Okay, so we obtain this number line. Now I'm just going to put a dot for each of the scores above the appropriate point in the number line. And if I have more than one data point that's equal to that same score, then I just have more than one dot on the plot. So let's see, we'll start with 81, 79, 78, 76, 83, 92, 69, 74, 76, 79, 85, 68, 77, 78, 79, 95, 88, 84, 81, 73, 72, 72, 74, 66. Okay, so there's our dot plot. So you see that's a lot easier to read in terms of how the data is distributed. We can say that most people scored in this range, maybe like we could say from 72 to 85. That's the vast majority of the students. It's easy to see what the high score is and what the low score is. The fact that hardly anyone scored above 85 hardly anyone scored below 70. So you just kind of get a picture of the data. It allows you to identify the trends. Okay, so next we have the stem and leaf plot, which is covered in the textbook. To be honest with you, I've never seen this anywhere but a textbook or in the homework that my kids bring home from school. So it's something that's taught in the classroom, but I don't know how much it's used outside of that. So in the stem and leaf plot, we make two columns, one for the tens, one for the ones. So on the left-hand side, we've got the tens, and the right-hand side, we're going to have the ones. And I just list each of the ones digits for each of the scores for that tens digit. So like for the 60s, we have 66, 68, and 69. So I just list them side by side like that. And then in the 70s, we have two 72s, a 73, a 74, no, two 74s, two 76s, a 77, two 78s, three 79s. Okay, so at the 80s, we have a pair of 81s, an 83, an 84, an 85, and an 88. In the 90s, we have a 92 and a 95. Okay, so this is another picture of the data. Here we're still seeing each and every score, but we're grouping the scores so that we can see the 60s, 70s, 80s, and 90s, and how those compare. But these are similar to each other in that we're seeing each and every score on the plot. So if we wanted to reconstruct the data set from the plot, we could certainly do that. Okay, but sometimes the data set may be so large that we don't want to see every score on there. We just want to see more general trends. So let's divide the data into intervals. And we have, it's natural, I think, to do 60s, 70s, 80s, and 90s. So we'll say that interval 1, we'll just call it 1, that's 60 to 69. Interval 2 be 70 to 79. Interval 3 is 80 to 89. Interval 4 is 90 to 99. And the number of values in each interval is called the frequency of that interval. So I have to look on my previous chart. So we have 3 in the 60s, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Looks like 13 in the 70s, 6 in the 80s, and 2 in the 90s. And let's just double check to make sure that adds up. So let's see, 16, 22, 24, 24 scores in all, so that's right. So these are the frequencies of the intervals. There's 3 60s, 13 70s, and so on. Okay, so now I'm going to use those frequencies to draw what's called a histogram. And a histogram is a kind of graph that you might be used to calling a bar graph, but a bar graph is actually a little bit different. We'll talk about that in a minute. Okay, so a histogram, basically, it's a bar graph for numerical data. So we've got 60s. I'm going to leave a blank space here. We've got the 60s, or interval 1, 2, 3, and 4. And put a blank space over here too. You'll see why in a minute. And let's see, we need the vertical axis to go up to at least 13. So need a little more space there. Okay, I'll just label the 2's since it'll be kind of crowded otherwise. Okay, now I just draw a rectangle of the appropriate height for each interval. Okay, the height is determined by the frequency. I'm going to put some little dotted lines. This is just to help me draw. It's not really part of the final picture. Okay, so this is 3. And then, okay, interval 2 goes up to 13. And then interval 3 has a frequency of 6. Interval 4 has a frequency of 2. And this is the histogram. And has this interesting property that if I were to regard each interval as 1 unit wide, and the height as given by the height of the bars, if I add up the areas of all these rectangles, it would be 24, which is the total number of data points.